Dah.
Hai, Assalamualaikum warahmatullahi wabarakatuh. We are from Group G. We are going to present about the stereoisomerism. My name is Muhammad Izzuddin.
My name is Azrul Iskandar.
My name is Leona.
My name is Intan. My name is Izati.
My name is Haris.
My name is Hafizam.
We are going to present about our organic compound, and our compound is 4,5-dihydroxyl-2-hexene. Okay, I will explain about the structure of this compound. So, the double bond is placed at the second carbon because the name is 2-hexene, and the hydroxyl group is 2 because the name of dihydroxyl, and it attached to the 4 and the 5th carbon because the name is 4,5. Then this compound has 4 stereoisomers because based on the formula 2 power of n, and the n is the number of chiral carbons. Then this 2 is the chiral carbon because the carbon is have 4 bonds that attach to the different groups or atoms. So, to make this more clear, this is the Fischer projection of this compound, and the intersection of this horizontal and vertical line represents the chiral carbons. And the last one is the 3D notation of this compound. So, the dash wedge represent the atom is away from us, and the solid wedge represent the atom is towards us. The structure of the molecule.
So this is the structure of the molecule. So up here is CH3, and then there's OH here at the right side, and then this one is CH3H6 here at the bottom, and then as you can see, this one and this one is the mirror image of each other, which is we call as enantiomer. So this structure is non-superimposable. As you can see, this structure and this structure, if you stack it like this, you can see that it is not non-superimposable.
As you can see, it is the mirror image of the first Fischer projection. So, as you can see, when the mirror image is there, the number 2, the OH group is at the different side of the compound. This compound, the OH group is at the left side. So, but we as Leona said earlier, we can stack the compound. So it is a non-superimposable mirror image. So it is the enantiomer.
Okay, seterusnya kita akan berpindah kepada struktur yang kedua, iaitu stereoisomer yang kedua.
Ini adalah stereoisomer yang kedua, iaitu kita mampu lihat pada kedudukan OH yang berbeza dengan seperti yang Leona dan Azrul bentangkan sebentar tadi, iaitu kedudukan OH adalah pada sisi yang sama, manakala yang ini adalah pada sisi yang kedua. Apabila dimirrorkan, Haris,
Kedudukan OH akan jadi di sebelah kiri, dan juga yang pertama, yang kedua akan berada di sebelah kanan kedudukan OH-nya. So apabila kita pindahkan dua molekul ini, kita akan dapat dia adalah superimpossible atau non-superimpossible. Dia akan dapat non-superimpossible.
okay, sebagai analogi mudah, apabila tangan kanan dan tangan kiri sebenarnya adalah mirror kan, tapi bila kita stackkan bersama, ibu jari tangan kanan akan berada pada sebelah kiri, manakala ibu jari tangan kiri akan berada pada sebelah kanan.
Seterusnya kita pindah kepada Fischer projection kan. Macam yang Izzuddin cakap tadi, Fischer projection, bila line ni bertindih, dia akan mewakili sebagai chiral karbon. So Hafizam, kenapa CH3 ni ke atas manakala C3H6 ni kat bawah?
Okey, seperti yang kita sedia maklum bahawa CH3 adalah lebih mudah untuk teroksida. Jadi dia akan berada pada sebelah atas, manakala C3H6 dia kurang berbanding dengan CH3. Jadi dia berada pada bahagian bawah. Haris, kalau kita ada COOH macam mana pula kita compare dengan CH3?
So COOH akan diletakkan di atas, manakala CH3 akan di bawah. Seterusnya kita akan pergi kepada relationship between the enantiomers dan juga diastereomers.
Okay, so we are going to talk about the relationship between these stereoisomers. Okay, so for the first one, we're going to talk about enantiomers. Okay, what is enantiomers? Enantiomers is the stereoisomers that has mirror image of each other. So for stereoisomer number 1 and number 2, number 1 is the mirror image of number 2. So both of these are enantiomers. So for this one, stereoisomers number 3 and stereoisomer number 4 is the mirror image of each other. So stereoisomer number 3 and stereoisomer number 4 is the enantiomers. Okay, so for enantiomers has the same boiling point and it has the effect on plane polarized light. It can be rotated to the right, which is dextrorotary, and rotated to the left, levorotary.
Okay, next we move on. Okay, the other type of stereoisomer is diastereoisomerism, which is opposite with the enantiomers. Okay, we have 4 stereoisomers here. So this 3 and 1 is diastereoisomers. Why? Because diastereoisomers is a stereoisomer which is non-mirror image. Okay, so 3 and 1 is not mirror image, right? So they are diastereoisomers. Same goes with 3 and 2, and then 4 and 1, and 4 and 2. So we have 4 pairs of diastereoisomers. Okay, so for the properties, diastereoisomers have different melting point, boiling point, and the polarity. So the conclusion is our compound, which is 4,5-dihydroxy-2-hexene, has 4 stereoisomers, and they have 2 pairs of enantiomers and 4 pairs of diastereoisomers. So that's all from us. Thank you.
Okay.